I am happy to be, as the Jeopardy host used to say, not the star, but just the facilitator here. So I'd like to start by starting saying the event really is about, as the quote says, bringing together experts from across the edge computing and IoT landscape to discuss trends, challenges, and opportunities. This session is about security specifically in that space, so as it applies to, as we quoted, the edge computing and IoT landscape. Security is pretty broad. I mean, it can be theft, it can be vague things, physical versus virtual, or damage, or stealth versus known. Security is a very, very broad term. So we have here 4 people who are each experts in their own space and with some overlap. And what I'd like to do is, since we only have 25 minutes, introduce each one, just the name and where they work, and give each one a few seconds, a few moments to describe what they do that's interesting. And then we'll have one discussion question, I hope, 2, and then close out. And hopefully we'll all learn quite a bit from here. I know I'm looking forward to it. So in no particular order other than I actually wrote them down, or we'll do the order that they're on the screen. Andrew Krug, who's over at Datadog. As I said before, you can see it quite easily from that great shirt he's wearing, and I have one as well, even if I'm not wearing it at the moment. So Andrew at Datadog, you want to introduce yourself for a moment?
Hi there, Andrew, technical evangelist at Datadog, specialized in security, primarily identity and access management, and serverless security, which has some crazy overlap with IoT.
I think everything about IoT tends to be crazy, and that's what makes it interesting. Next across my screen is Reid Hinkel, who is over at ARM. Go ahead, Reid. You want to introduce yourself for a moment?
Sure. Thank you, Avi. I'm Reid Hinkel. I'm the ARM transformation architect, and I work with our industry ecosystem of partners, from silicon partners all the way up through OEMs and integrators, on how to deliver best on ARM solutions in the most secure manner. So I've been in embedded security for about 25 years, and also digital rights management. So I have a significant background, and I work with most of the open source projects that ARM works within the open source community.
That's quite the broad space. Quite a deep experience. Next across is Kate. Kate Stewart has been doing embedded systems. Well, she's now doing embedded systems at the Linux Foundation. I'm sure she's done a lot more than that. Kate, yours?
Thank you. Yeah, my focus at the Linux Foundation is what we need to do to make embedded systems dependable. I'm also a member of the Zephyr Project's PCERT team, so focusing on open source projects, interacting with the security infrastructure. And the other area I tend to focus on is what do we actually need to do to improve the software transparency so that people actually know what software is running on their systems. And as we interface into these resource-constrained devices, there's some interesting challenges.
And last but not least, and I hope he's not upset, he's the person I've known the longest here, Erik Nordmark over at ZEDEDA. Erik?
Yeah, hi, Erik Nordmark. I'm chief architect at ZEDEDA, and as part of that, I'm working on the Eve project in LF Edge. So this is, the piece of software that we have contributed and working with others to advance things on the edge computing side of things. And my sort of background is building in various companies over the years, basically figuring out how to do robust and secure systems without being an expert in the individual pieces, right? But how do you actually put together the system to make that have the desirable properties, and sort of background around networking and having seen what does the internet do, both in terms of providing great connectivity, but also opening up lots of different threats that weren't there before.
I will take the personal moment to add that Erik's also a nice guy who helps with things that are not officially part of his thing, and he spent hours with me figuring out IPv6 at home. So painful, and I appreciate it. So he's a nice guy too. So the first discussion question, hopefully we'll have time for both, is to narrow it down. What security challenges do you see as being perhaps unique or stronger or different at the edge than in a data center? And to be clear, it isn't necessary for each person to have the same topic. You can comment, you can agree or disagree. It can be different. You each bring different expertises to the space. If it relates to your specific area of expertise, that's great. Some areas that I've seen people speak about are things such as dealing with things like root of trust when it's an uncontrolled space, software provenance, bills of materials, the contrast, for example, between the need for more metrics in order to be able to have better security controls in an uncontrolled space, but you have less bandwidth to get them. I think all of these are relevant at the edge, and there may be many more. I guess I'll be polite. Maybe we'll go in reverse order, then we introduce people. So if Erik won't get upset with me for bringing him on first, please.
Well, I was actually going to bring up one that might not sort of be as obvious. I mean, I can speak to other parts of this puzzle too, but at a high level, it's a combination of what you have to do sort of in a cloud or data center setting, combined with what you need to do in embedded systems. But you're getting data or getting software that some of it might come from an embedded environment where the assumption is that there was no network, right? Hence, you only had to worry about someone at the keyboard, mouse, plugging in a USB stick in front of this machine. Well, now it's connected to the network. And you're also getting software that comes from the cloud environment where the assumption is that, well, this is running in a protected, physical, secure environment. You have your security groups, whatever, firewalls, intrusion detection systems, and you're bringing that out to the edge. So it's sort of like, okay, there are different assumptions here. And to some level at the edge, you have to be able to deal with both of those. But one thing that is sort of might be forgotten in this, if we talk about this sort of static aspect of the system, is, well, we're going to have bugs, right? We've always had bugs. Some of those bugs are going to be security relevant. Well, what does it mean to be able to fix those bugs? Well, you have to be able to patch the system. And in a data center, we know how to do this stuff, right? Because we have various infrastructure, we have management networks, we have Pixie servers, remote power control. You can always go and re-image the server from scratch. Out at the edge, we don't have that, right? Maybe you have an LTE connection or a satellite or something. So what does it mean to be able to do that? And furthermore, if something goes wrong, many of the devices at the edge, they're sort of unique in their physical position, right? They're connected to these sensors or to this particular Ethernet with a bunch of sensors on it. So you can't just say, I can replace it with another one. Like, if a server goes kaput in the data center, you can just pick up an next one in the rack next to it. You can't do that. To the robustness of being able to both securely as well as robustly being able to update that software, right? No matter what, right? It sort of can't break at that point in time, and it can't be a backdoor to get security, to introduce security issues either, right? That's something that is part of the overall puzzle that is fundamentally different at the edge because of these different assumptions.
Are you saying that at the edge, almost in some cases, we're going back from cattle to pets? And all the implications that come with it?
No, not really, but I mean, at some level, well, there are pets. There are pets in the sense that, well, the only thing that connects to these sensors in this wind turbine is this particular one, right? And maybe there's a redundant one next to it if these sensors are really important, or you have redundant sensors in that wind turbine, right? But you can't sort of say, well, I have racks and racks of these things on the East Coast, on the West Coast, in the UK, and I can go to any one of them. It's like, no, you can't do that, right? But you can still treat them as, from an operational perspective, as cattle, but you sort of have to make sure that, well, I shouldn't, just because I'm sloppy, lose one, right?
So they're not quite pets, but they have behaviors that if you're not careful, you can end up treating them as pets. I rather like that. I was going to go in reverse order, but if somebody wants to jump in, just jump in, or at least flag somehow.
I was going to sort of build on some of what Erik was saying there, in the sense of completely agreeing with everything you're saying. The other side that's there is having a secure connection and working all this within the resource side. So in the resource constraint space, connecting to the edge from the sensors and actuators and so forth, what you don't want to be seeing is the garbage in, which will throw off all the measurements and calculations you're doing. And so these things don't want to be, you want to be able to make sure that you have that secure connection established, and you can actually potentially look at securely updating if there's a vulnerability that's determined in some of these devices. Some of them you're just going to throw away and turn off, at the end of the day. But having that secure connection established up from these data points up to the edge, and then basically being able to actually know if these devices are impacted by vulnerabilities as they emerge, because they're being discovered all the time. That is probably one of the areas that is needing further improvement, and we need to improve the transparency of what's going on there. So there's work going on creating software bill of materials, being open software bill of materials completely for your system. from the edge devices to the sort of, to the, from the resource constrained sensors and actuators, and exactly what's running on that software. It's the software that's running on your servers and what's going into the cloud. Having that line of sight transparency as to what's running.
Wait, I lost the last sentence. I think the audio faded out. The line of sight.
Transparency.
Yeah.
So being automatically queried. We've just seen the BlackBerry vulnerability emerge on our market in the space the other day, and knowing that what you're actually running on some of these devices, some of it's just like people put things in, start it off, and they're not tracking it effectively, and making it easy to automate the tracking of these things is an area that needs to be continue to be refined and improved on. There's initiatives happening now in that direction, and so building on that and making sure it makes its way from the edge, from these constrained devices that are providing the data to the edge, up to the cloud, that are doing the analysis is key.
I see both Reed and Andrew shaking their heads. I saw Andrew shaking his head particularly strongly a moment ago as soon as you said something about tracking it through, and I'm sure observability is flying through. Reed, will you forgive me if I jump to him, even though if I'm not going in perfect reverse order?
No, that's fine.
Yeah. I was just talking about the software there rather than the data.
Yeah, but the two do tie, and essentially tracking your software and knowing your state needs observing it. Andrew, are you about to jump in something there?
Yeah, pretty much agree with everything that's been said so far. And I think as we're talking about this, we have to really distinguish like old edge compute stuff from new edge compute with regard to these conversations, right? Because we've learned so much from SCADA systems and industrial controls and the sort of pseudo Ethernet protocols around them that for a long time people did either assume the biggest security risk was a human at a keyboard in the physical location with the device, or worse, they treated network identity like it was real identity. And that's a common anti-pattern that we continue to see, right? And then we have a new generation of edge compute with things like the K3S project and whatnot, where we have sort of a common set of things that we can double down on the security facilities that we're already really good at doing in the data center. So we can ensure integrity for the software in a variety of ways with projects like Toughen and Toto, and we can use traditional sort of observability tools at the edge to collect similar telemetry. But there's also challenges, right? Because these devices are constrained. You can't always monitor everything, right? And I think that's where hardware comes into it, right? So the more like kind of on-chip probes and things that make this computationally more efficient to do good observability on these devices, like the better a place we're in, because we're not kind of trading either observability or performance, right? But feel free to chime in, Kate.
So the observability I'm talking about is not what's actually monitoring what processes are happening on these devices. It's actually knowing the software that has been installed at the right exact version. And since that is being figured out when you're figuring out the images to deploy on these devices, you should be able to track that as well.
Yeah.
I would posit.
That's actually critical, both that element, and I think the biggest piece that we see the challenges at the edge is the diversity of the devices at the edge, and the range of scale of compute that they can do is important. But I think exactly how they're built, what they're built upon in terms of the instruction set and in terms of the actual architecture of the platform, and how do you secure it. When you're, in a data center, you have gates, gates, guards, and guns, so you're not worried about physical tampering. You're worried about a lot more things at the edge than you would normally be worried about. So from ARM's perspective, we've been very active beginning at the very baseline when you boot the system, establishing the secure root of trust, because if you don't have a secure root of trust on the platform, you can't build everything that you need on top of that. What we've worked to do is then harmonize that root of trust so that it works across all devices in terms of the principles behind it. How it's implemented might slightly change, but then we create a certification and test regime on top of that to make sure that you can actually validate that the root of trust has not just the robustness level that you're targeting, but also the access to the various features, including attestation, which is exactly what Kate's talking about. And how do you scale attestation between something that can do PKI-based authentication versus things that cannot. So we're basically working through various different standards in the industry, including the entity attestation token, so that you can actually do tokenized validation and make against the claims of the device, which might include the software versions that are on the device. So there's a whole infrastructure that needs to be there on an edge device that you might not need in the data center, and it needs to be scalable from microcontroller to advanced microprocessors at the edge.
I find it interesting how you said that diversity of devices is a bit of a challenge. It's obviously a challenge. Everybody had these big smiles when you said that. I think a lot of people here had scars in some way or another from it. I think you're saying that to some degree, the reasonable standardization or relative homogenization that went on in cloud centers has to some degree spoiled us. Do you see at the edge things starting to consolidate towards a few generic minimal resource capabilities and minimal platforms, a few ARM, a few Intel, a few this, and a lot of these other devices being left behind? Or do you see some sort of way to sweep the rest in?
Well, there's a lot of greenfield activity going, but in our view, you have to go back and you have to consider that most of the industrial IoT is brownfield. So whatever you can do, you need to make it go back as far as you can and find ways to retrofit it. And in some cases, some solutions to this are to put an interim device in between your device, which would typically be connected to to the internet and something else. So, for example, that's exactly what Microsoft Sphere achieves. So what they do is they assume that the devices that were already out in the field might not have the capabilities to do the level of network security that they might need to do. They may not have the device identity. They may not be able to be patchable or updatable. So what they can do is put an appliance in between that can actually front end all of those capabilities. So there's a range of things that can be done. Long term, obviously, we want to think about how you do that entirely on the device and embed it into its very core software and middleware.
Interesting way to bring them in. Yep.
Yeah, but it might still be sort of, if you're looking at if you're looking at the actual deployment lifecycle for this, it might be that this pattern doesn't go away, right? That if things that are built tomorrow that have the latest crypto and hardware support for that and whatever, well, it's deployed for 10 years, or maybe in some environments 20 years, right? Well, what security threats, what bugs are going to be found in algorithms in 10 years that you need to fix them? Well, you might find that it's easier to sort of put this intermediary, this IoT gateway, whatever, to front even those down the road, right? So I think that pattern will be stable, even though we want to improve even the sort of sensors and actuators out there in terms of their security capabilities. Right?
So one of the things that's happening in Zephyr is we've got a code base that's evolving like Linux. So Linux is also another space, but you've got the ability to continually update and also do a refresh, so that you can actually apply these security fixes into certain spaces when it is available, and you can rev things, and being able to report that and actually keep things up to date with the current known state is something that open source lets you do, that may not always be as easy in other places, that you can have the secure updates, you can have the security capabilities. These capabilities keep getting added, and as algorithms get discovered to be flawed, you can put updates in them if you have the ability to do a firmware update in a secure fashion.
I'm going to latch on. I'm going to latch, and it probably will feed into what you want to say, Eric. I'm going to latch onto what you just said and your shirt, Eric, because the topic actually is not edge security, but edge security enabled by OSS. I was hoping to get into open source in this as well. You did it with Zephyr, so I'm going to try and grab that and see, and I'll turn it back to you, Eric. The question was supposed to be, what role do you see open source playing in security at the edge, or specifically, does it help, hinder, or neutral? I'm not sure if that's where you're going to go, Eric, but you're wearing the open source shirt, and Kate just raised the open source project, so please.
Yeah, no, I mean, I think that it actually helps a lot, right? Because not only is there lots of good open source out there and projects that have sort of good ways of handling, security issues, right? I mean, many of these things build using Linux, and like we're building using hypervisors like KVM and Sun, and lots of other components, right? And so people are paying attention. And people have over the decades actually developed good sort of open source auditing tools. And this is continuously improving in terms of being able to get tracked, right? You can get notifications in GitHub saying, hey, by the way, did you know that you're depending upon this version of this other package that has a CV against it, right? You might want to go look at this stuff. It just sort of happens automatically, right? The state of this is actually advancing quite quickly. It has to, because the actual software dependencies are also quite complex when you're building large systems. But compared to sort of doing this with, I go and acquire some different piece of commercial software, I have no idea, right? I don't have the same level of transparency to know what's the state of security in there.
So I was remiss in mentioning that in terms of the platform security architecture and many of the different things that ARM's participating in, we do have reference examples and actual in-use examples of all of the enabling software in open source form. So trustedfirmware.org, you can find everything from our microcontroller trusted firmware, which Zephyr actually incorporates, to the actual our microprocessor level software, trusted firmware for A-core type devices, all available, including our trusted execution environment called Opti, which is also available at trustedfirmware.org. And then we contributed into the UEFI firmware level, so the actual fundamental part that sits right below the OS, where we believe it needs to be the level where you have the updatability, the attestability, and all of that portion needs to exist before you even load the OS or the hypervisor. So those are the elements that we're focused on most intensively. But as you can imagine, ARM has a lot of engagements beyond that, but all based upon this single foundation.
Andrew, OSS.
It's no secret. I'm a big fan of open source software for a variety of reasons. I think as a customer, I almost look for things to be open source as a means of reassurance first, because oftentimes you can't actually audit commercial softwares depending on the license on your own. And I like the ability to do that, but I'm also just a firm believer that the more eyes that you can have on a project, the better the security of that is going to be. I have friends who do projects that they call bugs for breakfast, where they do automated bug hunting across all of GitHub and try to find at least 3 or 4 bounties they can close out before breakfast. So no doubt, like OSS is a massive force multiplier, but also a lot of the security innovation that we're seeing in this space is coming out of open source, like Linux Foundation, CNCF, with projects for bootstrapping identity, with projects for software bill of materials like Tough and InToto. So just lots of innovation there.
An interesting piece too for commercial software, don't be fooled if you're receiving a commercial software binary. There's a high likelihood that there's going to be a lot of open software embedded in it, in which case you need tooling that can actually allow you to go inside those binaries to search for it. Because if there's a security vulnerability in the binary, maybe the commercial company that actually sold it is no longer around, and you need to be able to know that that's there so that you can actually report your vulnerability. So going back to the way to do it up front and transparently versus brownfield, where you have to go out and figure that out and protect against that.
And one of the things we're looking at for trying to do it transparently is actually being able to generate a software bill of materials for these constrained devices, where you're taking it and mapping literally every source file you're including to the binary. And so we've actually just finished adding that capability into Zephyr with the last release. So it was actually a good talk yesterday on it, which overlapped a bit before this, that just basically is saying that, you can put an option on the build and you can generate yourself bill of materials. And that's where we need to move the industry, in my mind, so that we can actually have the full traceability back down to the source files. Because, hey, if a version of a file, a version of a package is impacted, well, if you're not using that functionality in the package, or you're not using, that specific stack in your image, you're not impacted. But right now, you really can't tell. So we really need to get it down to the source file level, and so we can automate it properly.